Myself Justin Paul Matthew from Computer Science and Engineering Department. Today I would be explaining you the implementation of a binary search tree. So I have started with the header file hash include stream and then using namespace std. Then I have created a structure and I named it as tree node, and then I have created two pointers left and right of type tree node, and then I have created a data of type integer, and then I have initialized the head pointer as null, and then like void insert 2 is a function to insert, and then inside that as arguments I have given pointer temp and pointer monk of type the structure type, and then I'm checking whether the temp arrow data is less than monk arrow data, that is the root node is less than a monk arrow data or not. If it's less than, then I'm checking whether the monk arrow left is null or not. If it's null, then we can say that monk arrow left is equal to null. Monk arrow left is equal to temp. Let me before that let me explain you what is a binary search tree. Binary search tree is a tree which has at most two children, and the property is that all the elements which are less than the root element should be in the left side, and all the elements which are more than the more than if 10 is there as the root node and 20 comes, then it should go to the right side. That is, the elements which are higher more than the root node should go to the right side. That is the property of binary search tree. So I have created a insert function here, and then if it's not null, then I will be calling the function again so that it goes to the next node and check whether that monk arrow left is null or not. It goes till it finds the null condition and then insert it at the leaf node, and then we can see else if it's greater than monk arrow data, that is temp arrow data is greater than monk arrow data, and then inside that again we are checking whether monk arrow right is null or not. Here monk is the root node, so monk arrow right is null or not. If it's null, then we can say monk arrow right is temp, the same step which we followed in the up, like which in the lesser than case. So again we will be like calling the insert to function with the like the next node and the temp value. So I hope you understood this inserting function. Now here what I'm doing is created another insert function. Here what I'm doing is I will create the new node and then I will pass this node. Okay, so here to create a new node, I'm initializing a temp pointer of type tree node, and then using temp I'm telling temp is equal to new tree node. Then temp arrow left and right I'm initializing it as null, and then temp arrow data I'm giving the value of item to temp arrow data, that is the element which I want to insert. Then here I'm checking if head is equal to null, that is that there is no node at all. So the element which we are inserting that becomes the root node. So else if it's not null, that is root element exists, then we will go to tree node star monk is equal to head. Then from here I will be calling the insert to function to perform the insert operation. And then the tree node has three type of traversal, that is in order, pre-order and post order. What happens in order is from the root element it will go to the left, then it goes on to left till it finds null, and then print the data, then check whether it has a right child or not. If it doesn't have the right child, it will go to the next previous element, then check the right element. That way it is proceeding. Like for in order it is left, data, and then right. For pre-order it is data, left and right. For post order it is left, right and then data. So here in order traversal I have given the root node, and I am checking whether the root node is null or not. If it's null, then we can't print. So if it's not null, then I am we know recursive function, right? From the function itself, we will calling the same function. So I am calling again the in order monk arrow left. That is, it goes to the left node, and then again it will check whether monk is null or not. Then it will go till it finds a null. If it finds a null, then monk arrow data will be printed, and then it will go to the right. So in the same way pre-order also, again we are checking whether the root node is null or not. If it's not null, then we are printing the data. This time the data we will be printing it first, and then we will go to the traverse through left and right. In the post order, first we will go to left and then right, and then we print the data. In the main function I have initialized three variables x, n and d, and then while of 1, and then here I am like displayed three function. One is for insert and second is for show. and then I'm asking the user to enter his choice. So inside the switch case, in case 1 I am asking the user to enter the data. Once the user enters the data, I am calling the insert function, and then in case 2 function I have, like I told you, there is three type of traversal: pre-order, in-order, and post-order. So I have again asked the user that which order he or she wants to traverse. So here again, for pre-order traversal, I will be calling the pre-order, and I will be passing the root node. And for case 2 in order, I'm again calling the in order function and then passing the root node. For post order traversal, again the same thing. And then case 4, like go to previous, like if he wants to return from this, and go to inserting the element or not, and then it comes out of the loop. So I hope you understood the program. I'll run this program and show you. So enter the choice. First I want to insert, so 10, then again 1, it should be 20, 130. Now if I want to show this element, I'll be like the three type of traversal. First I'll be showing it in pre-order traversal. You can see 10, 20, and 30. Then in order traversal, 10, 20, and 30. For post order traversal, 30, 20, and so from here I want to return. I'll come back and then exit. So I hope you understood the program. Thank you for watching my video.